right, for number 11 here, we have a polynomial equation, x cubed plus 512 equals 0. All right, and when we solve a polynomial equation, we want to factor it. We don't want to do this. All right, we don't want to subtract 512 and take the cube root, because then we're just going to get one answer, -8. And that is one of the answers, right? That is one of the answers. But there's two other answers, right? And the two other answers come from factoring and doing the quadratic formula. So a good rule of thumb is that when you have a polynomial of degree n, so this is a third degree polynomial, all right, it should have three answers. And you can find all of them by factoring. So now we're going to do this a different way, and we're going to still get this answer. And we're going to do it by factoring. When you have two terms, that means you could factor by the difference of two squares formula, the difference of two cubes formula, or the sum of two cubes formula. Those are the only three formulas we know for a two-term polynomial. So we're going to factor using the sum of two cubes formula. Look it up when you use it, and the more you look it up, then you'll memorize it. And it's a pretty simple formula once you get to know it. There's no coefficients. It's just going to be a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. All right, so if we take this and we write it like this, we get x cubed plus 8 cubed, and that means x is a and b is 8. That's going to factor to x plus 8 times x squared minus 8x plus 64. Okay? Now that this is factored, remember it's equal to 0, we could take each factor and set it equal to 0 and solve. So we still get our answer like we did before, the -8. And then our other two are going to come from taking that quadratic factor and setting it equal to 0. Now when you do the sum or difference of a cube, this part shouldn't ever factor. All right, there might be a GCF if you forgot to pull it out earlier, but you're going to have to use the quadratic formula here, and you're going to get complex answers. So we get x is equal to the opposite of -8 plus or minus the square root of -8 squared minus 4ac all over 2a. So we get 8 over 2 is 4 plus or minus the square root of 64 minus 4 times 64. Okay, 4 times 64 is 256. So when we add that to 64, subtract it from 64, we get -192. And I didn't divide this part by 2 yet, so I still got to put it over 2. Okay, 192 is a perfect square. 190, not a perfect square, but it has a perfect square factor. All right, 192 is 64 times 3. So if we break up -192 as -1 times 64 times 3, okay, we could simplify root -192 as 8i root 3. Okay, 8i root 3. And we're still dividing by 2. So that 4 over 8 becomes a 4. So our final answer is 4 plus or minus 4i root 3. And those are our other two answers. So now we have 1. These are two answers, 2 and 3. All right, so 3 solutions for this polynomial. All right, so moral of the story, you get a two-term polynomial. Try to factor it. See if it's the difference of two cubes, difference of two squares, or sum of two squares. Then factor, set each factor equal to 0 and solve. And you'll have to use the quadratic formula for this part here every time.